This video is for Advanced Algebra. Lessons 7.2 and 7.3 are going to be combined in this video. 7.2 talks about properties of powers. 7.3 talks about properties of powers with negative values or negative numbers. So for this video, I'm combining the two lessons together so that we can talk about all the properties of powers at the same time. So students can see here that the assignments for both are slightly reduced. Normally I would assign 1 through 20 or 1 through 30. And so since we're doing two lessons at a time here, I've reduced them slightly. Keep in mind as well that this would be a baby calculator lesson, so students should not be simply typing in these types of questions onto their graphing calculator and generating the answer without thinking. Students need to apply the properties and then use only a baby calculator to help them. So what students are going to do first of all is look at all the different properties and try to start to commit some of them to memory. There are names for each of these, and I don't need students to memorize the names. What students need to do is be able to recognize one side of the property and how it relates to the other side. There are pieces to these properties that I've put in red here to try to emphasize the piece or the element of that property that stands out. I've also tried to arrange them in such a way that they kind of relate to each other. So we're going to start out with the very first property here, the one on the upper left. When you have a base raised to a power times the same base to a different power, all you need to do there is add the powers together. As opposed to when you're dividing by two numbers with the same base, you can simply subtract. And there are reasons for that, which I will be explaining during class. If students need to see it visually, they should ask me to explain to them individually. So when you have two bases that are the same and you're dividing, the exponents get subtracted. You do need to pay attention to the order here. The top one comes first and the bottom one is what you're subtracting. When you have one base and you're raising it to two powers, as opposed to multiplying in the first one, you would multiply the two exponents together. So here we're taking one base and we're raising it to two powers, so here we would multiply to get the result. As opposed to the very first one where we're doing two separate bases that are being multiplied together, we add. Here we've got one base to two powers, so we multiply. When you have multiple bases going on, you can take the power that's on the outside and distribute it to the two pieces on the inside separately. So here we took away the parentheses and put the power with both bases separately. When you're dividing and there's parentheses, again that power can get distributed to the top and the bottom as separate pieces. Two additional properties here. When you take any base and raise it to the zero power, you always get a 1. And here I wrote the property in quotes because this is something that students need to just simply memorize in words. Raising to the 0 is always 1. Similarly with negative exponents means you're going to take the reciprocal of the base. So remember that every power has a base that it's attached to. So we take the base, if we're raising it to a negative, all that happens is the base flips over, or we do the reciprocal, and then we take the power of that. So let's put these properties into practice now with some examples. Before we do that, there are a few little quick review items in the homework that I want to just touch on, and then we'll get into specifics of powers. Students will need to know the area of a circle formula, so let's just quickly review that that is pi r squared. R represents the radius of a circle. Radius of a circle is the distance from the center of the circle to any edge. Keep in mind that if they give you the diameter, you might need to take that and divide it by 2 in order to get the radius. So there will be questions about the area of a circle. I just wanted to quickly review that for students who had forgotten. Scientific notation is another one that's going to come up in this lesson. Let's just review the structure of problems that are in scientific notation. The first piece of a scientific notation number is going to be a number between 0 and 10. So it'll actually be a number less than 10. It'll be something like 1 or 1.2 or 6.7, but it won't be a number ever larger than 10. Then you'll see usually an x, which means multiplication here, not a variable, and then you'll see a power of 10 after that. The power of 10 will represent the number of zeros that should be contained within the number if it weren't written in scientific notation. So here's an example. If you take 12 and divide it by a 9 with 7 zeros after it, you're going to get on your calculator most likely this type of answer. 1.333 with a bunch of 3's after it, and then an E, and then a -7. That is your calculator's version of scientific notation. So what that means is, first of all, a number between 1 and 10. Now that 3, since it continues, we'll put a bar over it. Keep in mind that that's different from saying 1.33 with a bar over it. Whatever's being repeated, you just write it once and put a bar on top. And then we say times 10, and the number after the E is the power that you're looking for the 10. So this means 1.3 repeating times 10 to the -7 power. So now that's written in scientific notation. So the first one that we have written here, this would be what the calculator would say, and this would be how we would write it on our paper. If you're asked to write it not in scientific notation, you would need a little bit of scratch work or scratch room here. So I'm just going to write my 1.3. And I'm going to ignore the repeating for now because I am going to be rounding off the number. So I write the number, and then because it's 10 to the -7, that means the decimal point needs to move to the left. If it was a positive number, I would have moved it to the right. So I'm going to move this 7 times. Since I've got no digits there, I'm going to incorporate some extra zeros after I'm done moving it. So actually I'll incorporate those now. And I think I need one more there. So now I'm going to move that decimal point 7 places to the left. 1, 2, 3, 4, 5, 6, 7. So now I've got 0.1, 2, 3, 4, 5, 6 zeros, which makes sense because I had the 1 to get around first. So that would be the value of the number approximately, not in scientific notation. So scientific notation is just a condensed version or a condensed way of writing a number that's a super small or super large decimal value. So there might be situations in the homework where students encounter that, and I wanted them to have some skills to represent that. Now let's get into some practice problems related to powers and the properties that we talked about today. So here we've got 2x cubed times 3x squared. The 2 and the 3 are being multiplied together, so I'm going to just do 2 times 3 there. I know that that's going to make a 6. And then I've got x cubed times x squared. So I've got two bases that are the same. So I know from my properties that when I've got two bases that are the same, I want to add the exponents together. So I'm going to say that my answer is 6x to the 5th here. To double check it, use your knowledge of powers. X to the 3rd simply means x times itself 3 times. X to the 2nd also means x times itself twice. We are multiplying those together. So 1, 2, 3, 4, 5 x's are being multiplied. That's why it's x to the 5th. So if you don't remember what the property says, just utilize your knowledge of powers to figure it out. So we use the property, but know that you don't have to use the property. Let's try the next one. This time, we've got a base being raised to 2 powers. So this is different from what we did on the previous question. The k is being raised to a 3 and to a 4. So this time I want to multiply the two properties or powers together. So I'm going to say k to the 12. If you're not sure that that's the right property to utilize, think about what the power is telling you. It's telling you to take k to the 3rd and multiply it by itself how many times? 4. So if I took k to the 3rd and multiplied it 4 times, I'd get 3k's there, 3k's there, 3k's there, and 3k's there. And if I'm multiplying all those together, count how many k's there are all together. There are indeed 12. So that's why that property is a nice shortcut to know, because it allows you to simply multiply the powers together and then you're done. We're going to apply that same property here on number 3. 4 squared cubed I'm going to take my 4, and I know that because I have two powers here, I'm going to multiply them together. So 2 times 3 is 6. And now if I can, I'm going to go ahead and simplify further. 4 to the 6th, if I type that in on my calculator, that's going to be 4096. Know that that's not the only way you can do it. You can also say, well, because of the parentheses, 4 squared, I'm going to figure that out first. So 4 squared I know is 16, and then I still need to cube that. So I could take 16 times itself 3 times, and that would still get me my same answer of 4096. So know that you can just use the order of operations here, or you can utilize the property. You should always try to come up with a final answer though, if you can. So 4 to the 6th, we can figure out what that is, so you should always get a final numerical answer if you can. Looking ahead to number 4. Number 4 has two bases that are the same, and we're dividing. So the powers here should be subtracted. So I'm going to say m to the 8 minus 3, which simplifies to m to the 5. Let me show you visually how that works. If you have 8 m's on the top, and you have 3 on the bottom, m divided by itself will cancel or make a 1. And so when I cancel those out, that leaves me 5 m's on the top. So again, if you forget the rules of the property that they should be subtracted, you can simply write it out without using the powers, and you'll be able to see the answer pretty easily. Questions like number 5 really throw kids off, so I want to make sure that you pay extra special attention to number 5. Students mistakenly believe that they need to distribute the 2 here to both pieces on the inside because of the presence of the parentheses. However, the parentheses here simply mean multiplication. So I'm not going to be distributing here. I would distribute if there were a plus sign in between these two bases. Because there isn't, this is simply a multiplication question. So the parentheses here are actually meaningless. So really this question is the same as doing x squared times x to the 3rd times y to the 6th. So because these two bases are the same, I'm going to add those powers together. So I get x to the 5, and then the y is a totally different base, so there's nothing for me to do there. So I'm just going to leave that as y to the 6th. Because those bases are different, I can't do any further simplifying there, so I just leave my answer with x's and 5's, or excuse me, x's and y's. Now when we get into a problem like number 6, now things do need to get dealt with in terms of the parentheses here. Here I have a power of a power, so that's my priority. I want to figure out what x to the 5th cubed is before I deal with the 3x squared. Powers of powers take priority. So here, because I have one base and two powers, I'm going to go ahead and multiply together. So my 3x squared is just going to sit there for a little bit while I figure out 3 to the 5 to the 3, excuse me, x to the 5 to the 3. So here I'm going to multiply the properties or the powers together. So I end up getting x to the 15 there. Now I've got two bases that are the same, so now I'm going to add the powers together. There's nothing for me to multiply the 3 by, other than the 1 that's in front of the x. If that number were like a 2 or something else, I would go ahead and do 3 times 2 there. But there isn't, so the 3 just stays. Now because I've got two bases and two powers, I'm going to go ahead and add. So I get 3x to the 17 there. Moving on to number 7, more with division here. When the bases are the same, I can subtract because of the division that's happening here. So I know when I'm subtracting, I do the top minus the bottom. So what I'm going to get here is x squared, y to the, now be careful here, this is y to the 1. So when you're subtracting a 4 and a 1 here, you will get y to the 3rd. And then be careful here on the z's. I've got 1 on the top and 4 on the bottom. That's going to leave me with z to the negative 3 when I subtract. Or you can write the z on the bottom. So we could say x squared, y to the 3rd, and I could leave the z on the bottom because one of them cancels on the top with one of the ones on the bottom, leaving me 3 more on the bottom. So I'd accept either answer there. Typically when they have you write answers, they're going to have you write it without negatives if you can. So this isn't a wrong answer, it's just typically you want to keep going and write it without any negatives. So that gets us into a question like number 8 that has a negative exponent in it. So remember, negative exponents take the base and flip it over. So I'm going to write 1 over 3. The power travels with it. As soon as it gets flipped over, it becomes positive again. So the 3 and the 2 stay together, but the 3 moves to the bottom of the fraction. So now I'm going to simplify. 3 squared is 9, so I simply get 1/9 there. Now what do you do if the base is already a fraction, like in number 9? You do just what you did in number 8. You need the reciprocal of 1/2. So we had a 3 in number 8. The reciprocal of that is 1/3. In number 9 we have a 1/2. The reciprocal of that is 2. As soon as the base gets flipped over, the power becomes positive. So I flipped it over. It's now positive. 2 to the 3rd is 2 times 2 times 2, which is 8. And then finally, let's end with number 10 here. You have in parentheses 5x cubed y to the 5x squared y to the 3rd. It's being raised to the 0. Be careful here. Is 5 to the 0 and x squared to the 0 and y cubed to the 0, is that equal to? Yes, it is equal to a 1. Whenever you raise anything to the 0, you'll always get a 1 back. I'm going to add one additional question here that we're going to call number 11. Let's call it x to the 4th, y to the -3. If you're working with a question like that, there's really not a whole lot you can do here in terms of combining the x and the y, because the x and the y are different bases. But there is something we can do to change the problem. Because of this negative on the 3, we can rewrite it as x to the 4th, and then the y to the -3, flip it over. That becomes y to the 3 on the bottom. When you flip it, now the exponent turns positive. So there wasn't really any simplifying to do on that question, but there was a way that we could utilize a property to rewrite it in another way.